This one more back in the back. Okay, so usually the question is quite straightforward. So it would be something like this. Now, the main reason why I'm keeping the number low, if you still remember, when we talk about metal, yield strength of metal is what? Still remember any of those? Like, kind of mentioned that briefly at the end of the class. Yield strength of metal is around 200 to 600 MPa, depending on the metal itself. So if you see the number in order of hundreds, you start thinking, are we okay with the theory that we're using? We have to start thinking about that. So as long as the number is low, we're still following the linear elastic deformation assumption. Now, right now, I have x, I have y-axis, or x prime axis, and let's say that this number is 25 degrees. So the question is, number one, what are the stresses on the elevated angle theta equal to 25 degrees. Number two, what are the principal stresses and their orientation. Number three, what is the maximum in-plane shear stress and its orientation? So three different questions based on the picture here. So again, this is sigma x prime that we need to find. We also need to find this tau x prime y prime. So the triangle on the picture should help you find number one very quickly. Number two and three is just doing the substitution and all. So from this process, sigma x is what? Positive 10 MPa. That's what you have to be able to retrieve from the picture. Sigma y minus 40 MPa. tau xy negative 20 MPa. Now those are the part of the solution. If anyone have difficulty translating from the picture to those three items, please let me know. Because that's going to be the very important step in getting like a perfect score. This is one of the questions along the way in the semester to do really well in this class, because this one is kind of like the easiest concepts. So from here, we say sigma x prime is going to be sigma x plus sigma y over 2 plus sigma x minus sigma y over 2 cosine of the 2 theta plus tau xy sine of the 2 theta. If you write it several times, you will remember what it is. So again, this would be 10 minus 40 over 2. You still need to do the mapping process. So again, this is going to be 10 minus 40 over 2. So this is going to be 25 cosine of 50 plus tau xy. This is minus 20 sine of 50 degrees. This is MPa. So let me do this. Minus 30 divided by 2, so minus 15 plus 25 cosine of 50 minus 20 sine of 50. So in the end, this is minus 14.25 MPa. So which means that when you have the answer that's going into a different direction, like having a negative values, you should redraw this picture. So it means I should redraw this. But I'm too lazy, I can just copy and paste. But in your exam, you have to do the redraw. So right away, I get the first, this one, 14.25 MPa going in. So again, this is 25, this is x. Again, tau x prime, y prime, you do the substitution, again you get a negative over 2 sine over 2 theta plus tau xy cosine of the 2 theta. So again, this is going to be 10 minus 40 over 2 sine of 50 degrees. Put the big parentheses, minus 20 cosine of 50 MPa. So substitution will give you negative, positive 50, 25, negative 25 sine of 50, negative 20 cosine of 50. So we get negative 32.0 MPa. So it means that this one going into a different direction as well. So this is 32 MPa. for you is that, do you understand that this is negative 32 and the arrow right here, let me do like a highlight, the arrow right here is going down. That negative corresponds to the arrow coming down this way. Do you have any question on that? Now, if this is your x prime, most of you have in the previous classes, so I will explain it. So this is positive x in terms of the area. That means this is your y prime. So going down here is a negative y prime. That's why when I get a negative values over here, the arrow must be in the negative. Okay. That's what it means. Okay. So that's question number 1. We're doing the substitution here. If it's a question for the stress transformation, you get like a 1 point. This is 1 point. Substitution like this doesn't work that much. Usually the picture here is another point. So it's not much out of 10. So again, here, no points, but you're supposed to be doing it right anyway. If you're doing it wrong, then it will affect everything that you do, along with the substitution and everything. Okay, so after doing this, we have to continue by going on. So let's say that we already done this. So we have to go on to the second question, where we ask for the principal stress and the orientation. So right now, it means that we should find the R. R itself, easiest way is to do this R. Square root sigma x minus sigma y over 2 squared plus tau xy squared. So this would be 10 minus 40 over 2 squared plus minus 20 squared. This is an MPa. So we have 50, so that's 25 squared plus 20 squared. This is 32.02 MPa. This is your R. And you need to find the sigma average as well. So sigma average is just sigma x plus sigma y over 2. And 10 minus 40 over 2 MPa, and you get minus 15 MPa. So this is part of doing question number 2. It means that right now, sigma 1, we already have the answer. Sigma average plus the R. And that means you have 32 minus 15 minus 15 plus 15. Yeah, oh, yeah. Wait. So it's minus 15 plus 32, so that's 17.02 MPa. And then sigma 2 is sigma average minus the R. So minus 15 minus 32.2. This is going to be minus 47.2 MPa. So So we know the maximum and the minimum. Now the fact is we know those two, we need to know the theta p. So two of the theta p itself, if you don't remember, then you have to do the differentiations again. And if you do remember, tau xy is equal to x minus sigma y over 2, then you have minus 15, wait, tau xy is minus 20, sorry. Arctangent of minus 20 divided by 10 minus, sorry, minus 40. So this will be plus 40. 25. So this is 38.66 degrees. That's that's the two theta p that I have from the arctangent. So minus 20 over 25. So in this case, what do I do to this theta p? I just put it in the formula, and this one is your sigma average, which is minus 15 MPa plus sigma x cosine of, wait, sine of, cosine of, that's right. Sometimes I have to recheck. Minus 38.66 degrees plus the minus 20 sine of minus 38.66 degrees, which is MPa. Now you do that substitution, and what do we have? Minus 15, 25, times cosine of minus 38.66 minus 20 sine of minus 38.66. So I get 17.02 MPa from here. So this means that this is your theta P1, or 2 theta P1, sorry. Doing the substitution so that we know that after the substitution, the value that you got is the maximum. Sometimes, you know, you do the arctangent, you might get theta P2. So this is like a process that you have to go through. So it means that theta P1 is going to be minus 38.66 divided by 2, so minus 19.33 degrees. Now from here, what does it mean to have a minus? Theta going positive this way. So having minus meaning, if this is your x-axis, this is your x-axis, that means you should have the P1 19.33 degrees. that means I can draw. Let me try to draw this particular. This is your P2, 90 degrees apart. And that's 70.67 degrees. And again, this is your theta P1, this is going to be your theta P2. It means that over here, this is your 17.02 MPa. Sorry. And this is your sigma 1. And your sigma 2 47.02. So, wait, is it 0.02 or 0.2? I think it's 0.02. Minus 15 minus 32.02. 0.02, sorry. So this is 47.02 MPa, and this is your sigma 2. So this is the stress element. So starting out, you have the objects, for example. We have these objects, and then I put like a box around, and I get the sigma x, sigma y, times xy. And then I say, well, this frame of reference does not give me the maximum values yet. So what I do is I rotate until this point, until I get to this point. And then I say, okay, this is going to be the orientation that gives me the maximum value of the stress. That's going to be where the failure starts. If it fails or if it breaks, it's going to be along this line. Okay, because that's the maximum. Any question on this? Yes? Right. They're not related. They're not related. The triangle that we started is actually from this. So if you see this triangle, it means that the orientation we start with is this. It's actually this 40 MPa. This is 10 MPa. This is also 40. And this is 10 MPa. And this is your 20. The triangle actually gives us this initial stress element. So what we do here is that we rotate this stress element by forming another triangle. And what we do here is that we cut this part Let me put it here. We got this part, and we got this triangle, and this one is your signal one, and that is 17.02 MPa. And then you still have everything else the same. If we don't do that, MPa, this is 20 MPa. Now, this is signal, but then I was like, what about the minimum? I'll cut another line saying that, okay, I'll do this cut, and I'll do this cut, I'll do this cut. And that cut will give me this stress element right here. So it's just that cut. So when I say not related, it's not quite not related, but it's a different question that I asked. Okay, it's a different question that I asked, but it's the same point. Same point on the objects. We just do a little different frame of reference. Does that answer the question?
Professor?
Yes.
In the first part, when you listed all the values, can you scroll up?
You mean this?
Yeah. Why is all of the forcing like the opposite direction? Like sigma x is like plus 10 is in the opposite direction.
On the left side, that a negative x area. So the direction of the force is in the negative x. That means the stress must be a positive. So if you happen to have, the picture being complete as an element, if you have a negative 10, if you have 10 going to the left over here, that means on the right it has to be 10. But since this was a negative x-axis, it might be a little bit more difficult to see what it is. So you always have to imagine back to the positive x and see whether or not the direction of the arrow going in the positive x or negative x before making the plus or the minus values. Is that something? Okay. Any other question? We haven't finished this yet. It's still not complete. This is just number 2. Number 2, you need to have this stress element after doing the substitution. So usually, I would be like, this is probably 4 point on all of this. So this is going to be like 3 point, or actually this might be 2 point, half a point, and this is like 1 point, finding the values. So if trying to allocate the whole question to 10 points, this is going to be the distribution of how it goes. Any question before I move on to the third part? The third part is quite the same. We already know that your R, it was 32.02 MPa. That means tau max is going to be 32.02 MPa, and tau minimum negative 32.02 MPa. So we have to figure out the data S, and the data S itself is the arctangent to data S arctangent of sigma x minus sigma y over 2 over tau xy, right? If you don't remember, we keep going back to the differentiation. So again, this is going to be arctangent of x minus y is 50 divided by 2, so minus 25 over minus 20. So this will be a positive values. So arctangent of divided by 20, this would be 51.34 degrees. Quite the same, we're using this number to do the substitution. So tau x prime y prime equal to minus, so this is 10 minus of minus 40 over 2. This would be sine of 51.34 degrees plus tau xy, that's minus 20, and cosine of 51.34 degrees. This is in MPa. So what values do we have? So 25, so minus 25 sine of 51.34 minus 20 cosine 51.34. This is 32.02 MPa. So what does this mean? It means that this is a negative values. I mean, this is going to be 2 delta S2. That means it gives you the minimum values. Because you need to find the substitution first. Substitute, you get either maximum or minimum, but then, with this substitution, you get minimum. And it means that right now, I can start plotting. So, delta S2 equal to 51.34 divided by 2, 25.67 degrees. Usually, when you do the plot, you're going to have, the angle that's only in terms of the degrees. So it's going to be around 26. So it means that if this is your x, this is your S2. And this is 25.7 degrees. So quite the same, you go down to make a complement of 90 degrees. This will be 64.3 degrees to get to S1. Doing my best to have my S1 and S2. So 25.7. Okay, so S1 gives you the maximum, which means if this is x prime, this must be y prime. That's like a little note to yourself. So I don't keep it onto the drawing. So in here, it means that the direction over here, this would be tau max going positive. This is 32. MPa. And this is going to be tau minimum. Also 32.02 MPa, which means that this and this would have to be drawn in the picture. And we have minus 15 MPa, so this is 15 MPa, and that's your sigma average on all surface. 15 MPa. 15 MPa. Okay. So this is the maximum in-plane shear, which is this one, max, tau max in plane equal to 32.02, and according to that, theta S1 is minus 64.3 degrees to answer that question. Now, this is the whole process of stress transformation using the formula that I give you. So again, formula in red color is given. The rest is something you have to figure out yourself. So it might not be that easy if you don't know how to use the formula. So this is Q&A before I jump into the next topics, which is related to this one, will make your life easier actually. But then of course, you have to know this one first before going into another approach for stress transformation. Sorry before something. Question from you guys? No question. I mean, you don't understand? Okay, ask please. Where were you lost? You know what we're trying to do, right? So the basic concept is very important. We have an object. Have this big object, and you're trying to find the stress at the point, and at that point maybe it's not what we want, so we kind of redraw the frame at the same point. So it means that you keep rotating theta until you hit a certain theta p, and that will give you a maximum. That's the main concept. So the question is, besides these main concepts, what else that kind of stopped you from like knowing how to do this? Yes, please. Okay.
So usually we have to follow the magnitude in the direction of the push maximum.
Right.
So just draw the maximum for the arrow.
So whatever surface you have, you think of that as a positive for the surface. And if you have the tau x prime y prime being negative, you use the right hand rules. This is always x prime, this is always y prime. So if it's a positive value, that means it's going to go up according to the right hand. Quite the same. It's always going to be switching plus minus on all the surface, because in the end it has to be in balance. The thing is, when find that this is S2, you find that this is a negative values. So it means that if this is positive x prime, this must be a positive y primes. The direction has to be here in order to have a negative values on the S2. Does that help, though? I was looking for a question from you because you seems like...
Later.
Okay, you can do it later. All right. Next, I will do just the concept because if I have to go through the whole question, you will be even more lost. You already lost here, so I'll go over just the concept. The concept is quite straightforward. Let's say that we have the equation, not this one. Let me kind of go back and copy this. Okay. If I have this equation right here, to start with, what we can do is we can say x prime minus, I'll put this as a sigma average, minus sigma average plus, well, not plus, equal to sigma x, sigma y equal to cosine 2 theta tau x y sine 2 theta. What I'll do is I'll square both sides. And I'll do the same for this bottom one. So it means I'll do the square on the bottom one as well. And what I do is, this will be equation number 1, this is equation number 2, 1 plus 2. On the left-hand side, I'll get sigma x primes minus sigma average square plus tau x prime y prime square equal to this term squared plus this term squared. Now, I don't want to spend time writing it out, but in the end, what you will have is that on the right-hand side, it will be equal to that r squared, or it will be equal to sigma x minus sigma y over 2 squared plus tau x y squared. And this is the equation that has been derived from the stress transformation, and we call this a Moore circle. Exactly the same equation that we had before, but we manipulate it, square it, add them together, and then, many of the terms cancel one another, and you end up with this equation. Now the indication of the stress transformation is this. We have what we call parametric equation. If we say this is theta, and we say this is sigma x primes, and we say that we have another axis as tau x prime y prime like this, what we end up having in terms of the parametric equation is going to be a spiral like that. With the spiral like that, what you do is you look at the spiral from the theta point of view. And when you look at the theta, at the spiral from this point of view, you end up having the axis, and the axis that we have, actually this is probably something different. Hold on. This is tau x prime y prime, sigma x prime. From what we end up having is that we're going to have sigma x primes, tau x prime y prime like this, and then that spiral itself would create an infinite circle going around when you look at it from the data itself. I will show that to you the next time we have the class. I'll plot this for you and I'll rotate the three-dimensional object so you will be able to see that the three-dimensional spiral actually become a circle itself. So that's the concept of the Mohr circle. And the circle itself will make things a lot easier for you to do the calculation. That's the main concepts. Now, I'll go through this very quickly on how to draw the circle. Sigma average is actually center of the circle. So when you have sigma x, tau xy, sigma y, like that. What you need would be the very surface. Positive x, I will call this surface A. So it means that when you have the circle, I'll have this as sigma x prime. In the end, that sigma x prime will be just called sigma, and tau x prime y prime, we will be just calling it tau. And then, of course, this plotting for the surface A will give you a point. That point itself is your sigma x, tau xy. That will be a point in the circle. Sigma average is going to be another point of the circle, and that would be your sigma average and 0. When you have 2 points, you can just use a compass and draw. And that's it. You get yourself a circle. So with the 2, you can draw around this. Not quite the circle that I want yet. Okay, this looks better. So again, you have 1 point, 2 point, draw the circle, and that's it. We'll learn more about the circle next week. You just have to be able to know how to start getting the circle. Do you have any question on getting that? Center and a point, draw. We'll add more detail about the circle next week. So we're going to end the class with Q&A. We actually have like half an hour left, but I feel like if I spend another half an hour on this one circle, you're not going to take it in. So I'll let you, digest a little, and we'll redo this again next week. Question?
What did the circle indicate here?
The circle itself indicates different values of the stress depending on the angle that you rotate the element. So this is the original point. It means that this line, theta equal to 0. And then if you start rotating and get to this point, you will get sigma x primes, tau x prime y primes. Over here, the angle will be 2 theta in the circle, but you will get the angle here to be the theta. And this is your sigma x prime, tau x prime y prime. Just the one that we did before. This is sigma y, sigma x, tau xy. Whatever you have on the circle would be the different surface orientation on the element itself. So when you rotate around the circle 360 degrees, you come back to the same point, but it means you go from theta to 0 to 180, which is on the other side of the objects. So again, 0, 180 degrees, get to the other side, but to this other side, it means that you come back to the same point in the circle. Pretty much. So it means that the circle itself does help you with the rotation of the element. We'll learn more about this. We have plenty of time today. I really want you to understand the basic concept before the circle. If you don't understand anything about the circle at all, don't worry. We'll come back and do it several times next week. Yes?
I'm not sure if this question makes sense or not. What happens if we go outside the circle? Assuming the barrier of the circle is the principal stress.
Let me try to figure out the best way to answer this. เลิก5 โมงครับ Okay. Anywhere along this circle is in plane rotation. There might be a chance that when you rotate, for example, you rotate this way at maybe like 20 degrees, then you do another rotation out to you. So, this is one rotation on one plane. But then when you rotate and stop and do another rotation, then you will go either outside or inside the circle. That's possible. And that's going to make things more difficult. You learn that in graduate school. So right now, in this class, I want you to just rotate in a single plane, and then maybe, toward the end of next class, I give you the glimpse of what happened if I rotate this just a little bit and then do another rotation. You will see a different circle. So the answer is, if you go outside of this circle, it might be possible that you are traveling on another plane of rotation. But it's still the same point. Very good question, by the way. Any other question from you? Okay. So again, the video that I posted, I think there are 3 different videos. One would be the pre-recorded, and the other 2 would be like 2 different semesters, I think. And since there was like a student, exchange student, I kind of give him like the background for statics. If you see him again, just tell him to watch the statics video as well. My recommendation is, if you come here to this class and you understand what's going on, you don't need to watch those videos. You really don't need to. But then if you don't understand and you don't want to, directly ask me a question, you can watch those videos. And you only need to watch just one series. I put 3 series there because I tend to give different exercise and questions in the lecture. So if you want to really be an expert, you can watch all those series, but I don't think you have that much time. So you don't need to watch the video if you understand what's going on. Anything else? If not, that's the end of this class. Those of you who have questions still, stick around. I'll be here until 5. See you guys next week.